911 online election. So for this problem, we are giving two integer arrays, persons and times. So for this class, top vote candidate, we're gonna have an init, and inside init, we're gonna have the persons and the times array. And in an election, the ith field was cast for persons I at the times I. Yeah, so in this example, let me just use the first example. At times 0, so we're gonna have a vote for persons 0. So at times 0, we're gonna vote for persons 0. At time 5, we're gonna vote for person 1. Yeah. So at time 10, we're gonna vote for this person 1 again. And for time 15, so we're gonna vote person 0. And for time 20, we're gonna vote for 0. And for time 25, we're gonna vote for this person 1. And for time 30, we're gonna vote this person 0 again. What are we gonna what are we gonna return? So we're gonna return the number of the persons that was leading the election at time t according to the method rules. Yeah. So for example, at the time 0, so we're gonna return a 0 because this person 0 just leading the board. Yeah. Just leading the election board. Now let's just check that. So in case of a tie, the most recent vote will wins. So for example, at time 15. So this is a time. Let's just try one by one. So at time 3. So our return gonna be 0 because for this person 0 at time 3. Yeah, because at time 0, 1, 2, 4, 3. So it's gonna be this person 0. But at time 12, so it's gonna be the person 1 because at time 12 we have this 5 and 10 because there are 2 elections for this person 1. So it is okay. We're gonna return a 1. So at time 25, we're gonna return 1 because at time 25 actually this is the latest time. There's a time and 25, so for person 0 and 1, but 25 is close to this 25. Yeah, most recent will wins. This is the most recent. This is why it's gonna return a 1. So this is important. And for this time 15, it's gonna return a person 0, and at time 24, it's gonna return person 0 again, and at time 8, it's gonna be here. It's gonna return person 1 because 8 is close to 5, even though there's a tie, but we're gonna return the most recent vote. Yeah, so this is the idea. Because there's gonna be 10 to the power of 4 calls will be made to this queue. So this means basically we're gonna use a binary search, because if we don't use a binary search, the time complexity is gonna be n squared, 10 to the power of 8. Definitely it will not work because it's gonna have 10 to the power of 4 times of this queue. So it means for each time of the queue, we're gonna use a binary search. But how can we use a binary search easily? And we know that the times I is 10 to the power of 9. So definitely we cannot use a times array. So for example, this is going to be the times array from 0 to 10 to the power of 9. Basically, we cannot do that because that's going to be time limit exceeded. Yeah. So we're going to use another to represent the time. Yeah. Because this is a offline search problem. It means before our binary search, everything is given. Because we are giving this person's array and we are giving this times array, because everything is given. So that means we can directly use the binary search to solve the problem. But how can we define the binary search? Yeah, we can directly use the time, and we can directly use the times array. So for example, this is the times array. So for example, if we are going to use a binary search to check maybe time 35, so what's going to happen? It's going to be the last index. So this is index 0, 1, 2, 3, 4, 5, 6. So it's going to be index 6. If we are going to use a binary search for this 35, definitely we're going to use a bisect left, binary search, bisect right. We're going to use a bisect right. It means at the right side. So this means if we are going to use a binary search to search this 30, so it's going to be, yeah, so we're going to find the index n. N is the length of the array, but we're going to choose the index n minus 1. So it's going to be, we can find the value of this 30. Yeah, definitely we can find this index 6. So the index 6 is going to be the result. So this means we're going to prepare a result array. So for each of the index, it's going to be a time step. So for example, this is 0, we're going to use the index 0 as the first time. So for the time 5, we're going to use the index 1. So for this time 10, we're going to use the index 2. Because all the numbers is distinct in times array and they are in increasing order. So this is what we are given. So we can use this kind of a property to solve the problem. So definitely we're going to turn this 0, 5, 10, 15, 20, 25, 30 to index 0, 1, 2, 3, 4, 5, and 6. Yeah. Now if we are going to use a bisect left to search this 35, definitely in the side array we're going to find this 30 and our index is 6, so 6 is here. Yeah. So now inside the result array at index 6, we're going to have a record of the final result. It can be 0 or 1. So because this is a time step counting, so from 0, 1, 1, 0, 0, 1, 0, so at the last step, definitely this is going to be 0. So this is why if we are going to search a 35, so definitely we're going to return a 0, because inside it will be 0 and 1. So for example, at index 0, we're going to have we're going to have the first vote, it's going to be this person 0, and then we have this person 1, because we have another person, they are equal, and we're going to choose the most close one, it's going to be this 1. And for the next, it's going to be 1, so for the second index, it's going to be 1, and for the next, it's going to be 0, yeah. So for the next, it's going to be 0, and for the index 5, it's going to be 1, because they are equal, yeah. So definitely we want to get such kind of result array. And then we're going to use a boundary search directly inside of the times array. We're going to find an index, and then we're going to use this index to find the final answer inside of the result array. So this is exactly n log n time. Yeah. So this n going to be 10 to the power of 4, and here maybe m. So this m going to be 5,000, because the length of the array is just 5,000 for the times array. Yeah. So in this way we can solve the problem easily. Yeah, now let's just use this kind of idea to solve the problem. So the result array, actually this is a times array. This means at different, so the index is going to be time. So definitely we have a mapping. So our mapping is this 0 maps this 0, this 5 maps this index 1, this 10 maps this index 2. So there's a map of 1 to 1. So we're going to use a smaller index value to represent the time. So after using the boundary search for the time, we find the index, and then inside the index we're going to find the person. It can be 0 or 1 or other persons. Yeah, so this is the idea. Now let me just try to solve it. So let me prepare going to be length of the times array, and we're going to prepare the self dot result. So it's going to be -1 times n, and we also need a times array. So the self dot times it's going to be equal to the times. Yeah. Now because we are going to check the person, we are not sure which one is bigger. So for example, here if there's a time, we're going to choose the most recent vote. But for this, for example, the person 0 or 1, we need to have a counter to count how many vote for the person 0 or how many vote for person 1. So definitely we need a counter. So I'm going to define a dictionary. So this is going to be a counter dict, and inside it's going to be an integer. And I'm going to set a current person. So the current person is going to be a none. So currently I don't know which one is going to be the current person. Yeah. So this is all the definition. Now we're going to update the counter self.dictionary, and we're going to check the current person, and we're going to get the self.result array. So this is what we are going inside the init. Yeah. Now let's just check the person one by one. So for I in read n, because the times array equals to the person's array, so this is okay. We can directly use the person. Yeah. So first of all, let's just update the dictionary. So it's going to be the person's array inside I. Person's I going to be updated to plus equal to 1. So this is for updating the counter. Now we are going to check this current. If current is none, or we're gonna check the counter self.d with this person. Yeah. So if this person's count is more than and equal to self.d with the current. Yeah. So if it is more than that, definitely we want to update it. Yeah. So the update is we're gonna set the current person. So the current person gonna be equal to this person's I, and after that we're gonna update the self dot. We're gonna update the self dot result. Yeah. So the self dot result I gonna equal to this current person. Yeah. So what did we get is let me just have a random return at the moment. So what did we do inside of the init? We just check the self.result array. So this is what we are going to check. So the result array is a time-based array. So currently we're going to use the index as the time-based array. So here we're going to get this kind of array. Yeah. So actually there's a mapping for this array. Yeah. So this index gonna have a mapping with the times array. So for the time, this means time 0, time 5, this is time 10, time 10, and this is time 15, yeah, and time 20, 25, and time 30. So this kind of index from 0 to 6 is gonna have a mapping with the time-based array. So this means we can directly use the binary search to search the time and find the index, and we're gonna get the final answer. Yeah, so this is why we're gonna design this kind of a self.result array. Yeah, so if everything's okay, yeah, so for here we prepare the self.result array. So if the current is nothing, so definitely we're gonna set the current as this person's I, and we're gonna record it inside of the result array. But if this person's count is more than the current person's count or equal to the current person's count, definitely we want to update the current, and we're gonna record the current inside of the result array. Yeah. So finally, we just need to return the answer. Yeah. But before that, let me just delete the print. So it's going to be self.result. So here inside, we're going to use a bisect right. So instead of a bisect left, we're going to use a bisect right. Yeah, because if the numbers equal, so for example 25. So for bisect right, we're going to first find this index 6, and then we're going to use the 6 minus 1 to find this number 25. Yeah. So inside of the bisect right, it's going to be self.times array, and then we're going to check this time. So after that, we're going to minus 1 to find this index. So currently, yeah, here we're going to find the index plus 1, but we need to minus 1 to find the current index, and then we're going to use the self.result with the current index to get the final result. Yeah. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. So the time complexity is n log m. N is the number of calls, it's going to be 10 to the power 4, and m going to be length of the times array, and it's going to be 5000. Yeah, so basically the time complexity is going to be n log n. I think that's all about it. Thank you for watching. See you next time.